Good afternoon. Thanks for sticking around here. As Tom mentioned, my name is Matt McCrann. Canvy specializes, they're a computer vision company, and we specialize in face recognition in the most challenging scenarios possible, real world, real time. So there's a lot of buzz around face recognition nowadays. Here is a snapshot of the current state of commercial face recognition. These are the common use cases for face recognition today. Image matching, so matching two photos in a database, or a smaller subset like a mugshot gallery. The second one, matching a photo to a secondary document, an identification document, photo ID, passport. And the third one is a consumer use case where the consumer will auto-enroll or self-submit an image that will then be checked against them at later stages for either authentication, authorization of either a transaction, logging into applications, or even with your iPhone logging into your device. Now, the key takeaway here is none of this is challenging in today's face recognition environment. There's several companies in the world that are capable of doing this and doing this well, well being 95% accuracy or better. These scenarios are all constrained scenarios where the face is taken, the face image is taken in a somewhat controlled environment with cooperative, or in the case of the mugshots, somewhat cooperative subjects. Canvy focuses on this. So this is what we would call wild imagery. These are examples here on the right-hand side. And this is the polar opposite of the constrained use cases. So as you see here, wild images introduce several variables that can be difficult for not only face recognition solutions to match a face with high confidence, but to even detect a face. So a lot of solutions, they don't see these faces. Canvy does. As you see in the case here, there's obstructions of the face, partial images, eyewear, headwear, that can make it difficult. Also varying quality, varying lighting conditions. So what makes Canvy uniquely qualified to solve these real-world use cases? Well, for one, we're best in the world at exactly doing just that, wild image accuracy. I am biased, but that's not just me saying it. We have been validated by NIST and industry benchmarks from several universities, including UMass, where we set a world record for 99.87% accuracy with those types of images that we saw on the previous slide. But we're talking real-world application here. So accuracy is a must, but so is speed. They need to be able to keep up with the real-time use cases that come with live video feeds. So we operate, we have sublinear match speed, and we are the fastest matching algorithm with CPU only, which means that you're not running GPU or a lot of horsepower to get this type of performance. So this is what it actually looks like, and it's very simple, as you can see with the image. So we're completely agnostic to the data source, meaning we'll take in your IP cameras, your CCTV feeds, webcams, tactical surveillance equipment, pop-up stuff, mobile device images, kiosks, whatever. We take that in, we match it in real time, and then we can put the verification and any associated information with that individual, push it to the existing third-party solutions used for visualization or access control or situational awareness apps. So the end user changes nothing about their existing mission, but plugs in this capability for authentication, verification, or background checks. Primary use cases for government for us is identity intelligence. Basically, who is this person? Where have we seen them before? And let's correlate that to all the other data we know about the situation. A key differentiator for Canvy is our ability to operate on the edge. So extremely lightweight solution, We operate on commodity hardware as small as smartphones, tablets, mini PCs, and even on a chip. So we have the ability to operate and perform this real-time matching standalone on the edge and synchronize into a larger enterprise solution as well if network connectivity is there. Security operations, basically your force protection, your base security. We can provide access control with face, multi-factor authentication for base, zone, or even building or room level. And then probably the most obvious, but is data analysis. So we chunk through lots of video, lots of imagery data, really quickly extracting the face intelligence and serving it up to the analyst or the decision makers. A use case here, or an example of that, would be solving the human trafficking or child exploitation problem, where this is, for the most part, being done manually still, with an analyst actually watching these videos trying to make an identification. We could remove that. So this is what it actually looks like in action. We have a subject enrolled in a database. That image, the enrollment image, is in red, and then subject comes in front of any camera system, anything that is plugged into our engine. We match in real time and then push out to third-party systems. Now, yes, if you're wondering, those are pictures of me, so do not report me. I am not a terrorist. But I use these images as an example to show you that the enrollment image in red there, that's the only image that the face recognition engine had of me. I obstruct the bottom half of my face, covering my mouth, chin. Then I show up on camera somewhere else with the whole top half of my face covered. The only common points between the two images are the nose and some cheekbone, and that matches 61 or 62% confidence in a real-time environment. So we're very modular in our approach. We can operate anywhere, enterprise all the way out to the edge or in the pocket. All of our capabilities, all of our solutions operate standalone as well as part of a larger solution. And we make it easy to integrate. So basically, industry-leading face recognition as a plugin. We have several ways of doing this. I won't get too into the details there, but if you go back and you tell your engineers API and finite state machine, they'll probably smile and know what to do with it. Here's some examples of what we've done on both commercial and government side with integrations. Key one is multi-factor or multimodal integrations, so face plus fingerprint, face plus iris, and then not only other biometrics, but other ways of identification, so RFID, barcode scanning, tying all that to a face. So now you can tie an individual identity with an asset identity. And we integrate with video management systems, kiosks, point-of-sale systems, pop-up trailers, you name it. So how do we do this, and how do we do this really quickly and really easily? We run anywhere, on anything, end-to-end. This is a tactical con-op, and this is my last slides, just to show you what a deployment would look like with several CANV parts in the mix here. So running on off-the-shelf mobile devices, you can perform ID verification, so basically mobile access control or mobile security. Check against watch lists with or without network connectivity, which is big when you're operating in zones that have contested networks. That can integrate with network to the larger picture, which can be the SOC or a vehicle-based system, which could run on a mini PC. So the example there is an Intel NUC, that small box right there, and it costs about $300 on Amazon. Our whole engine can run on that with a database about 2 to 3 million. So now you can perform matching capabilities with up to 10 live camera feeds off of a mini PC like that. So not GPUs, not big servers. Thank you.